Hi everyone, Dennis Foley from Acoustic Fields. A lot of you have been asking to see our rig here, or my rig that I work on constantly. So I thought we'd give you a little video tour of what we do here and what I do here, mainly in terms of research and development. So you can get a handle on it. This is just a simple 2-channel active speaker situation, horns. I do something kind of unique here. I use horns in a near field situation because I like the dispersion pattern from the sides. And we'll move in here and look at it, some of them here, some of the gear. So it's just a little 2-channel setup here. Got a little DAC, small EQ, active speakers here that are horns. Of course, I'm never happy, so I'm always fiddling and messing around with things, and you can see in the horns here that it's got the same cork and stuff that our theater has, and then our foam at the top, foam through here. Okay, so that gives you an idea of the gear. Now let's go to the side channels because it's important. We're doing a lot of primary, secondary, and tertiary reflections here with our panels, foam technology. Now this panel's 6 inches thick. We're going to do a whole series of tests and data for you so you can see the difference between a 2-inch, 4-inch, and a 6-inch thickness in the lateral and sidewall reflection. So we've been experimenting now. And then that handles middle and high frequency. But then we got to get to the low frequency, which is, always the big problem here. So let's get rid of this chair. And you can see some of our modules here. But if you look closely at this module here, and the top, we have an opening so we can add or subtract our carbon technology. And we carry this theme, module theme, all the way through underneath the desk. So a slow pan all the way around. Put our chair back here. Okay. And you can see the modules all the way around underneath it. So we calculate the amount of square footage that we have there, the thickness of the carbon inside, and of course we look at response, and we'll do a whole series of videos on there. But for purposes of this, I just kind of want to give you an idea of the rig, and then, a screen in the middle. But we can kind of monitor things here. Nothing fancy, nothing expensive. Remember, the room only sees energy, and that's what we're all about here. So let's take another little tour around this side here so you can see what's going on. Here's more 6 inches of our foam here with the wood frame around it. Okay. And then more of the modules here. And more with the opening so we can add or subtract carbon. Now, we just did a video on our theater, which you can see here. And this is the front wall of the rig. So it's 24 inches thick. We're serious about this. I mean, we're not playing around. And we don't stuff boxes full of building insulation. This is real diaphragmatic absorption with our proprietary carbon technology and our proprietary foam technology. So if you look, front wall 24 inches, and underneath our steel tables where everything sits upon, we have our modules. And then we calculate how much square footage is used in each one, how much carbon is used in each one, and what the response to all that is. So this is our rig. This is where I work. This is where, when you call in with your questions about your room forms in our 15-minute time slots, this is where I sit. If I don't answer the phone right away, I'm sure you can understand, what I'm doing here at that point. So just try back again in a few minutes, and I'll be able to get to you. But the goal here is to, we're trying to figure out what kind of square footage coverage we need. Do we need to create modules that have more horsepower absorb more energy per square foot? Is that the goal, to get that accomplished? And of course, it's always about cost-benefit ratio. How much energy can we absorb in such a small amount of space? We have really good data on what's involved with the whole process, but we want to try to refine that and get the most horsepower we can out of 4 square feet. Because from a construction standpoint and a building standpoint, that's an optimum size to maximize material usage. But these modules now are probably 80, 85, maybe 90 pounds a piece. And that's what we are trying to work on, lighten it up a little bit. I don't know if we're going to change the size any, but obviously I won't sacrifice performance at all. So there's the rig. Everybody can get a handle on what we're doing, and we're going to do a whole series of experiments throughout the year. So stay tuned, and we'll keep you up to date, and we'll go from there. Thanks. Hope this helps. Bye-bye. Thank you for watching this video, and if you liked it, please give us a thumbs up. We also have a newsletter that you can subscribe to, so please do that, because we offer special price discounts to only those on our newsletter. And then don't forget about our forum. We have started a forum on our own website where people ask questions, and I usually get a chance every couple of days to look at it. There's an interchange between people on the forum, and we'll give you real answers on a regular basis, so that'll help you. Thank you.